Good morning, students. Okay. So, basic concepts related to organic chemistry. Okay. So, board is visible, right? Fine. So, good morning. So, anyone, what we were discussing in the last class? Okay, Shashank already has given. Electromagnetic effect. We were started with the discussion about the electromagnetic effect. So before that, we have discussed about inductive effect. Before that, we were discussing about inductive effect. Right? So ಹಾಗಾದ್ರೆ inductive effect will be only in the presence of only in the presence of electron withdrawing groups or electron donating groups. So inductive effect will be observed only in the presence of electron withdrawing groups or electron donating groups. So that's where they differs from the resonance effect. That's where they differs from the resonance effect. All of you got my point? So in the last class, we had discussed about phenol, acidic character of the phenol, right? Then we have taken another example, which was the derivative of phenol, right? That is NO2. Then another common molecule, OH, NO2, NO2, then NO2. So these three are the molecules. Then we have included another one, OH, CH3, right? Now, based on the last class, now we know that acidic character is going on increasing when we move from left to right. All of you have understood? Acidic character, it will be increasing. So what I mean to tell you is, whatever I have written, that is the increasing order with respect to acidic character. With respect to acidic character. So what I mean to tell you is, what do you mean by acidic character? In this regard, release of H plus. Release of H plus. So based on that, whatever I have written, based on that I can see that 4-methyl phenol or toluene derivative, if you consider that one as a toluene derivative, then 4-hydroxytoluene, it will be weaker acid compared to the phenol. And when it comes to the phenol, it will be weaker acid compared to 4-nitrophenol, which will be weaker acid compared to 2,4,6-trinitrophenol, which is nothing but picric acid. So which is nothing but picric acid. So what is the reason why this molecule is a weak acid? What is the reason? This molecule is a weak acid because there is a substituent. There is a substituent which can show the positive inductive effect, or due to the inductive effect. Simply we can call that due to the inductive effect, where electron donating group like methyl groups are present. So therefore it will be a weak acid. Because when I am talking about methyl group, yes, positive, When I am talking about hydroxyl group, even that will show the positive decrease in the acidic phenol. Why it is having bit acidic character compared to other alcohol? That is because of the resonance effect. To be more appropriate, positive resonance effect. Because whatever phenoxide ion will be formed, it will be stabilized by positive resonance. Whatever phenoxide ion will be formed, it will be stabilized by the positive resonance. Okay, that's why phenol will be comparatively acidic if you compare with the other alcohol group containing molecules, especially alkyl alcohol like methyl alcohol, ethyl alcohol. Okay, so that's why we have the acidic character of phenol. Now when I am talking about 4-nitrophenol, it will be more acidic compared to phenol. So what is the reason? That is because we have a electron withdrawing group. So we have a electron withdrawing groups. That's why it differs from electron donating group. So here methyl group is an electron donating group, but here it is an electron withdrawing group. So therefore negative resonance it will show, inductive effect it will show, and positive resonance it will show, right? So positive resonance and negative inductive effect, so all together it will cause the higher acidic character, and same logic is applicable when I am talking about the picric acid. Same logic is applicable when I am talking about the picric acid. All of you got my point? So that's where we have, based on the whether electron withdrawing groups are present or electron donating groups are present. So based on that, as a character of a molecule is going to differ. That is the role played by the inductive effect. Okay? Any doubts in this? Fine. If you have any doubts, you can ask. So that's where we have the impact of the inductive effect with respect to phenol and its derivative. So day before yesterday's class with respect to hydrocarbon, where electron withdrawing groups will be present, we have discussed. That is with respect to acetic acid, then trichloroacetic acid, then we have discussed about 2,2-dimethyl propanoic acid. So there also we have observed that inductive effect is going to influence the acidic character of the carboxylic acid, that is carboxylic group. All of you have got my point. So any doubt in this? If you don't have any doubts, I will move to the next part. Any doubts, Sidya? Okay. So shall I move to the next one then? So that is with respect to electromagnetic effect. That is with respect to electromagnetic effect. Okay. So symbol is E. Symbol is E. Okay na? Okay, fine. So however, when I am talking about electromagnetic effect, so that's where it is related to those elements which are having pi electrons, or which are having a double bond or a triple bond. So which are having pi electrons. Acetic acid does not have any double bond between the carbons. Acetic acid does not have any double bond between the carbons. So no electromagnetic effect, means carbonyl group is there. So due to the presence of carbonyl group, it can show, but I am talking about these two carbons. Okay, so there is no double bond. So when I am talking about this particular molecule, and once again I will repeat, carbonyl group, C double bond O. Since double bond is there, they can show the electromagnetic effect, no doubt. But I am talking about carbon-carbon. Okay, so that's where electromagnetic effect will be observed wherever we have the pi electrons. Then what is the difference between resonance and electromagnetic effect? For the resonance effect to be observed, there should be presence of conjugated double bond. There should be presence of alternate double bonds. So that's where we have the difference between electromagnetic effect and resonance effect. Okay, all of you have understood? Try to discriminate between all these different terminologies. Anyway, at the end I am going to discuss that one. Fine. Now, yesterday we took the example of a reaction which is an example for addition reaction. Which is an example for addition reaction. However, what will happen in this case? Which is that example we have taken? So we took the example of ethene. We took the example of ethene. Now, when ethene is treated with hydrochloric acid, when it is treated with the hydrochloric acid, now all of us will know HCl is having a covalent bond. Don't think that HCl has a ionic compound. No, it is a covalent compound where there is a dipolarity, delta negative, delta positive. So there is a dipole moment, a strong dipole moment will be there, which you people have studied in chemical bonding. There will be presence of a dipole moment. Okay, that's where we have the HCl. Now, this HCl can be easily dissociated as H plus Cl minus, right? All of you will agree? It will be easily dissociated as H plus Cl minus. So that's what it will happen when it comes to HCl, which is a strong acid. Now, due to the presence of HCl, where there is a presence of electrophile after dissociation, and where there can be formation of a nucleophile. Okay, so that's where there can be H plus and Cl minus. There can be H plus Cl minus. Now, whenever there is a presence of nucleophile and the electrophiles, there will be shifting, displacement of electron will take place in a alkene or alkyne. Here I have taken alkene, which is that one, ethene. Example for alkene, double bond containing molecule, and we can call it as unsaturated organic compound. Whichever molecules, organic compound, if they are having double or triple bond, we can consider them as a unsaturated compound. Say for example, I have ethane, CH3, which is an example for alkane. It is saturated organic compound. It is a saturated one. Okay, but if I consider ethene, it is a unsaturated one. Same way, I have ethyne, triple bond, ethyne. Even ethyne can be considered as a unsaturated molecule. Sorry, not saturated, unsaturated molecule. So these two will be considered as unsaturated. So what I mean to tell you is, any compound, any organic compound, listen to me carefully, any organic compound where between the carbon, if there is a presence of pi bonding, that is the presence of pi electrons, there is a presence of double or triple bond. Once again, please remember, if I am telling acetic acid, acetic acid is not an unsaturated one. Sir, there is a carbon-oxygen double bond, but I told there should be double bond between carbon and carbon. Okay, so therefore, that is the compulsion with respect to unsaturated hydrocarbons, where double bond should be present between carbon and carbon, not with any other element. Fine. So in that way, I can tell that ethyne and ethene. They are the example for unsaturated hydrocarbons. But when I am talking about ethane, there is only a single bond. So therefore, it should be a saturated hydrocarbon. All of you got my point? Any doubt with regard to this one? That's where we have unsaturated and saturated organic compounds. When I am talking about ethyne or ethene, here I have taken ethene or any of the unsaturated hydrocarbons, they can easily undergo for addition reaction. A saturated one cannot go for addition reaction. It can go for substitution reaction. Listen to me carefully. If I take ethane, hydrogen, 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 then another hydrogen. Okay, so I have a molecule ethane. Try to understand this one. Ethane cannot go for addition reaction because all the carbons, they are saturated. They are having sigma bonds, 4 sigma bonds. So they are all saturated. So therefore, until unless I remove the hydrogen, a new bond cannot be formed. Whether I am clear? So until unless, if for example X is there, if X wants to bind to the carbon, that means any of these 3 bonds or any of this bond, it should be cleaved. Then only X can be added. Naturally, in that case, it cannot be a addition reaction. Addition means what? Nothing should be removed from the molecule. Another molecule should be, element should be added without removing anything. Then only it is called as addition reaction. Okay? But in case of the saturated hydrocarbon, addition reaction is not possible because all the carbons, they are satisfied. All of them, they are having the sigma bonds, 4 sigma bonds, they are satisfied. So therefore, saturated hydrocarbons cannot show the addition reaction. Addition reaction is only with respect to unsaturated hydrocarbons because since they are having pi electrons which can be displaced easily, and that displacement of the pi electron is called as electromagnetic effect. That displacement of pi electrons is nothing but electromagnetic effect. So if I want to define the electromagnetic effect, I can tell that. So this is the phenomena or this is the condition where there will be displacement of the pi electrons. There will be displacement of the pi electrons in the presence of attacking reagent will take place. Whether I am clear? So what do you mean by electromagnetic effect? It is the displacement of the pi electron in an organic compound in the presence of a attacking reagent. Any doubt in this? All of you got the answer why ethane cannot show the addition reaction? If you have any doubt, you should ask. Why ethane will not show the addition reaction and why ethene or ethane can show the addition reaction? All of you have got the answer for this? Any doubts with regard to this one? If you have any doubts, you should ask. Okay. So that's where we have the addition reaction. I will come back to electromagnetic effect now. Now when I am talking about addition of HCl across the ethene, addition of HCl across the ethene, these reactions will come across once again in the next organic chemistry chapter, that is hydrocarbons. Okay. Now naturally, since 2 ions will be there, now we will imagine this H plus is going to approach this carbon. Okay. Now when H plus is approaching to this carbon, Now there will be shifting of pi electrons towards one carbon. So which is that carbon? That should be this carbon. So whatever pi electrons are there, it will be shifted to this carbon because an approaching reagent is a electrophile. So electron deficient species. So it cannot invest any of the electron to make the bond with the carbon. Carbon has to invest the electron. Then only carbon hydrogen bond can be done. Otherwise, this H plus does not have the electron. So therefore, it will take up the pi electron. One belongs to this carbon. It will move to this particular carbon so that it can make a new bond with this particular incoming H plus. All of you got my point? Now, that's where there will be formation of a condition due to the shifting of electron. There will be formation of a condition, that is, this will be minus, this will be plus. One carbon will become minus, that is carbanion, and another one will become carbocations. All of you got my point? So that is because of the electromagnetic effect, displacement of the pi electron towards one carbon. Now therefore, H plus can easily attack to this carbon because of the electron richness. Now Cl minus can easily attack to this carbon because electron deficient. Got my point? So electron rich, electron deficient. Electron rich, electron deficient. They will go with each other. They will go with each other. That's where there will be formation of a product. CH2, Cl, then CH2 hydrogen. That's where ethyl chloride will be formed. That's where the product ethyl chloride will be formed. Any doubts? So I can rewrite this one as CH2, Cl and CH3. To make you understand, I have written this hydrogen with bond. Okay, that's where we have the product ethyl chloride. So this product is nothing but ethyl chloride. Okay, so how right? When I am talking about this addition reaction, where ethene is getting converted into ethyl chloride. Unsaturated molecule is becoming saturated molecule. Got my point? So due to the addition reaction, an unsaturated molecule is becoming a saturated molecule, that is ethyl chloride. In ethyl chloride, there is no double bond. Please remember, only single bonds are there between the carbon once again. So therefore, a saturated molecule, hydrocarbon derivative will be formed from the parental alkene. That is due to addition reaction, which will be mediated by the electromagnetic effect. Which will be mediated by the electromagnetic effect. So any doubts with regard to this one? Okay. So shall I move to the further explanation? Already I have explained this one. Shall I move to the further explanation? Fine. Oh, done. Very good. So in that case, I have two types of electromagnetic effect. So one is positive electromagnetic effect. Okay, and another one is negative electromagnetic effect. Right? So positive electromagnetic effect and negative electromagnetic effect. Fine. Now in this case, listen to me carefully. In case of the resonance effect, what do you mean by positive resonance effect? When electron will move away from the substituent. What do you mean by positive resonance effect? When electron will move away from the substituent. What do you mean by negative resonance effect? When electron will move towards the substituent. Observe it carefully. from substituent, when electron is moving away, we will call that one as a negative resonance, positive resonance. When electron will move toward the substituent, then we will call it as negative resonance by considering the double bonds, by considering the resonance molecule. But here it is opposite. Positive electromagnetic effect means where electron will move towards the substituent. Electron will move towards the substituent. So for example, now hydrogen is attacking to this particular carbon. If I want to number it, I will number it as 1 and 2. Ethene, anything you can number, but based on that molecule I have numbered it, because here chlorine should get the priority. So 1 and 2. So hydro H plus is attacking this particular carbon, second carbon. Now to which side electrons are moving? They are moving towards the second carbon only. So that means positive electromagnetic effect means displacement of the electron. Listen to me carefully. So positive electromagnetic effect means displacement of the electron towards that carbon. Displacement of electron towards that carbon to which attacking reagent is getting attached. Attached. Okay? So what I mean to tell you is positive resonance effect means displacement of the electron towards that carbon to which attacking reagent is getting attached. So that's where this is with respect to positive electromagnetic effect. Got my point? So with respect to H plus, if I consider, this is nothing but positive electromagnetic effect. Okay? And exactly vice versa for chloride. Right? Because this carbon, 1, chloride is getting attacked. Now electron is moving away from this particular carbon. So that is nothing but negative electromagnetic effect. That is nothing but negative electromagnetic effect. Fine. So what I mean to tell you is, in this reaction only we can observe both the type of electromagnetism. We can observe both the type of electromagnetic effects. That means positive also, negative also. We can observe here. What I mean to tell you is, electromagnetic effect, whether it is positive or negative, can take place simultaneously. Right? So CH2, so H plus is approaching here. So electron is shifted here. So Cl minus is approaching here. Now with respect to this particular condition, we can call it as positive electromagnetic effect. And with respect to this particular condition, we can call it as negative electromagnetic effect. So positive electromagnetic effect, negative electromagnetic effect. Any doubt with respect to this one? That's where there is a formation of ethyl chloride. I have taken a symmetric alkene, that is ethene. Okay, so we will discuss it later. For example, if I take propene, CH2, CH2, what is this? This is nothing but propene or prop1e. So propene. Now propene is an example for asymmetric alkene. Ethene is an example for symmetric alkene. But propene is an example for asymmetric alkene. All these things you are going to discuss in your hydrocarbon topic. Now, if I take HCl, I can expect, listen to me carefully, I can expect two products over here. When propene is treated with HCl, I can expect two products over here. One can be CH2, CHCl and CH3. Sorry. be CH3, I have written CH2. But my point, that is isopropyl chloride or 2-chloropropane or 2-chloropropane. This can be one product, and another product can be CH3, CH2, CH2, Cl. That is propyl chloride or chloropropane. Anything is fine. So I will make it specific. So 1-chloropropane or chloropropane. We can simply write it as chloropropane. So 1-chloropropane. Now there is a question. Sir, how come two products? 2-chloropropane, 1-chloropropane. How come it's possible? In ethyl chloride, it was not an issue because it was a symmetric alkene. But there, it is a propane is a asymmetric alkene. Now the question here is whether Cl minus or H plus, any one of these two you take. I will take Cl minus, whether Cl minus will attach to this carbon or whether it will attach to this carbon. How to explain this? Answer already we have done in few classes before. We have discussed about this. If you observe the electromagnetic effect, you will get the answer. The type of carbon which will be formed during electromagnetic effect. So based on that, you can give the answer to this question. This is once again you are going to study in your hydrocarbon topic. Please remember. Anyone can you tell me chloride Cl minus whether it will attach to second carbon or the first carbon? I want the answer. So whether I am going to get the 2-chloropropane or 1-chloropropane as the product. And answer, I am giving a hint by telling that depending on the type of carbon, after electromagnetic effect, you will get the answer. Anyone? Okay, according to Ashish, it will be 1-chloropropane. This one all of you have understood, right? I will remove this. So according to Ashish, it is 1-chloropropane. All of you will agree with that? Or any other answer? Who is going to oppose Ashish with regard to this particular answer? Anyone is there to challenge the Ashish? Now I am not telling Ashish whether he is wrong or right. Afterwards I will tell. Okay, Shashank is telling 2-chloropropane. Okay, now more problem. Equal vote. What to do? We are in democratic nation, right? Democracy. Anyone or any who is opposing either Ashish or who is supporting Ashish or Shashank? Okay, that's where you should apply the concept. 1 minute, Anupama, 1 minute. So that's where you should apply the concept of carbocations. You should apply the concept of carbocations. Now if you observe it carefully, either we can have the carbocation CH3, CH positive, then CH3. That can be one carbocation. Okay. Now another carbocation can be CH3, CH2, CH2, which will be formed during electromagnetism. Already I have added one hydrogen, that H plus I have added. Now which is stable? The stable one is this carbocation. This carbocation is stable. So therefore, 2-chloropropane will be formed instead of 1-chloropropane, which will be formed, but major product will be 2-chloropropane. So now who is the deciding factor here? Which product should be the major product? Who is going to decide? That will be decided by stability of these intermediates. stability of these intermediates. They are going to decide whether I am going to get that one as the product or this one as the product. Since secondary carbocations are more stable compared to primary carbocation, so therefore this will be found as an intermediate which will be attacked by the Cl minus. So 2-chloropropane should be the major product. 2-chloropropane should be the major product. All of you got my point? Any doubt? That's what you should apply whatever concept has been taught. That's one. That means you have understood the concept. If you have understood the concept properly, then you will be in a position to apply those concepts during the next concept discussion. Right? And already we have discussed that secondary carbocations are more stable compared to primary carbocations. Okay, fine. We will imagine still hydrogen is not added. Still hydrogen is not added. Then we have negative and negative, where H plus will be coming and where Cl minus will be coming. H plus will be coming and where Cl minus will be coming. Okay. So even in this case also we can tell this one primary carbon ion it is more stable compared to this one. So compared to secondary carbon ion. All of you got my point. So that's where we should understand the concept. That's where we should understand the concept. Otherwise, it is difficult. Got my point? So based on the stability of carbocation and based on the stability of the carbon ion of these intermediates, based on that product will be formed. So please remember, in organic chemistry you will be having two products, major product, minor product, and always we should focus on the major product, not on the minor product. This is the reason. That will be due to the stability of the intermediates which will be formed during the reaction. ಅರ್ಥ ಆಗಿದೆಯಾ? ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬಾರ್ದು. So what I mean to tell here is, I am ready to explain it once again. So what I mean to tell here is, when I am talking about propene, CH3 CH double bond CH2 electron, if it is shifted over here, then we have the intermediate as CH3 CH CH2. Since electron is shifted there, negative, positive. So what is happening? Secondary carbocation and primary carbon ion. This is the intermediate. If I take another approach, okay, if I take another way, that is CH3 CH double bond CH2. If it is electron is shifted towards this side, now I can have CH3 CH minus CH2 plus. So that means I have got secondary carbon ion and primary carbocations. So these are the intermediates which will be formed during the reaction. Okay. Now, since this is stable, since this intermediate is stable, so therefore Cl minus will come here and H plus will go here, and therefore we are going to get the product, major product, as CH3 CHCl CH3 isopropyl chloride as the major product. Okay. Any doubt? So that's where we should know which intermediate will be formed during the reaction. ಇದು ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. You should know how to apply those concepts which we have studied already. If you go back, you can see I have explained already about the stability of the carbon ion and stability of the carbocations. Already it has been explained. Now you should apply those concepts over here. You should apply those concepts over here. Then you are going to get the answer. Okay, na? Shall I move to the next one? So what do you mean by chemical intermediate or reaction intermediates? These are called as reaction intermediates. Okay, based on the stability of the reaction intermediates, those respective products will be formed. This is applicable for, in this case, this is applicable for propylene, not to the ethene, because ethene is a symmetric molecule, but propylene is an asymmetric alkene. So therefore, the problem is with respect to two types of product, major product and minor product. Fine. ಅರ್ಥ ಆಗಿದೆಯಾ? Yes or no? Whether all of you have understood, yes or no? Okay, okay. So that's why we have the electromagnetic effect. Now we can take another example. CH2 double bond CH2. Once again, addition reaction only. That is halogenation. That is nothing but halogenation. Hallucination allaha. Halogenation. That is with respect to addition reaction only. That is with respect to addition reaction only. So I have got ethene. When I am treating with bromine, other conditions we will not discuss here. For time being, imagine that we are treating with the bromine. Now what will happen? Bromination of ethene will happen. So bromination of ethene will happen. So where we are going to get CH2 bromine, CH2 bromine. Okay, that's where we have the product. So that is nothing but 1,2-dibromoethane. 1,2 dibromoethane. So ethene got converted into 1,2-dibromoethane, right? So that is nothing but vicinal halides. That product will be called as vicinal halides. Anyway, we will not go in detail with respect to that one. And once again, this reaction you are going to study in hydrocarbons and in second PU, organic chemistry. Okay, so that's why we have another example which is called as halogenation. Now if I take propylene, okay, so if I go with bromination, whether we can have major and minor product in this case? Any one of you? Whether we can have major and minor products in this case? Because E reaction, you could observe me carefully. In this reaction also we are going to get bromide and bromonium ion. Please remember, bromide and bromonium formation agutte illu kuda. Anion and cations will be formed. But my question is very simple. I have got a asymmetric alkene, that is propene. Whether I am going to have the major product or minor product? Or no major, no minor? Anyone? You can type it as yes or no. Whether you are going to get different types of product or same product. Yes or no? If it is same product, you should write it as yes. If it is different product, you should type it as no. Because I am telling that I am going to get the same product. Okay. So Ashish and Rakesh, they are telling yes. That means they are agreeing with me. Don't think since sir is telling everything will be right. Okay? Okay, even Geeta, she is telling yes, sir. So always Raghavendra sir is right. In this regard, it is right. Always I may not be correct, but in this regard, I am correct. Because since we are dealing with the same type of element, so therefore we can expect only one product. CHBr and CH2Br. Now, whether this bromine is due to bromonium or whether this bromine is due to bromide, we are not worried. Product is same. That is 1,2-dibromopropane. Right? We are going to get only one product, that is 1,2-dibromopropane. Okay, na? So therefore, there is no question of major product and minor product in this case. We are going to get the same product, that is 1,2-dibromopropane. Sir, what happened? In earlier case, you told major product and minor product. Why it is not happening here? That is because here both the attacking agents are same, that is bromine derivatives only. That can be bromonium or bromide, but they are bromine derivatives. But in earlier case, it was H plus Cl minus, two different elements were there. What my point? So that's why we are going to have the major and minor product in earlier case, but here there is no question of major and minor product. But here also there will be electromagnetic effect will be happening, where electrons will be shifted over here. Anyway, in detailed mechanism we will not go. There will be formation of a cyclic derivative, but anyway, we will not go. And this bromine is going to be cleaved, where there will be formation of bromonium and Br minus. So that's where Br minus will come here, bromonium will go there. But we are having the 1,2-dibromopropane as the product. Okay, so electromagnetic effect is also present over here. But it may not be easily explained because bromine are there. But based on the stability of the carbocation, we can tell that electron will be shifted towards this carbon because this carbocation will be stable. All of you got my point? Any doubt? So that's where it is an heterolytic cleavage. Pi bond is in a heterolytic cleavage where both the electrons are shifted to one carbon. Okay, both the electrons will be shifted towards the one carbon. Now, if that is the case, if you have understood, last one example I will give based on electromagnetic effect only. Last one example. Anyway, tomorrow we can continue with repetition and all. Fine. So I think today it is already time is that another 5 minutes. Now another example will be CH3, CH2, CH2, CH, CH2. Okay. So first thing, whether it is an unsaturated compound or saturated compound. First you should tell me whether it is unsaturated or saturated compound. Any one of you, whether it is saturated or unsaturated compound? Okay, fine. Yes, very good. It should be an unsaturated compound. It is an unsaturated compound. Why? Because there is a double bond between two carbons. So therefore, it is an unsaturated compound. One answer. What is the IUPAC name of this molecule? What is the IUPAC name? Yes, Geeta, it is unsaturated. Now, what is the IUPAC name of this molecule? Yes, very good, Shashank. It is pentene. This molecule is nothing but pentene. Pent 1E or pentene. If you write pentene, it's understood. At first carbon, there is a unsaturation. That is double bond because E. If triple bond is there, pentyne, Y-N-E. Now here it is double bond. Now, I am going to treat this product molecule with hydrogen cyanide. With hydrogen cyanide. Which can be the product you expect? Whether nitrile group, if it is attached to second carbon or first carbon, you should tell me. You should just type 1 or 2. My question here is whether cyanide or nitrile group will attach to second carbon or first carbon. According to Ashish, it will attach to first carbon. All of you will agree? Okay, everyone is telling nitrile group will be attached to the first carbon. Okay, but I will tell that it is wrong. That is because hydrogen cyanide can be dissociated as H plus cyanide minus, right? So electron, it will be shifted like this because this carbocation will be stable. So nitrile group will be attached over here and hydrogen will be attached over here. That means H plus will be attached over that. That means we are going to get the nitrile derivative of the pentene where to the second carbon nitrile group will be attached. Anupama madam, not the first carbon, it should be second carbon. You got my point? That is because when carbon electron will be shifted over here, we are going to get the carbocation of this type. That is secondary carbocation. If reverse is happening, then we are going to get the primary carbocation, which will be unstable. So those intermediate will be formed, which will be stable. So nitrile group should be attached to second carbon, not to the first. So that's where, due to this displacement, due to this electromerism, we are going to have the intermediate as CH plus, CH2 minus. This is the reaction intermediate. So therefore, negative electron nucleophile will go here and electrophile will come here. And the major product will be CH3, CH2, CH2, CH, Cn, CH3. Okay? All of you got my point? Any doubt? Okay, na? Fine. That's where we have the reaction. So try to practice with more examples at home. Okay, na? And tomorrow we are going to discuss and we'll be having revision about this particular topic. Because by this we are done with the organic chemistry. We are done with the organic chemistry. Okay? So any doubts in today's concept, whatever we have discussed? Okay, but you should practice. Please remember, organic chemistry cannot be learned as it is any subject, but organic chemistry requires more practice. Okay? But any subject, it requires the practice, no doubt. First, understand the concept thoroughly, then try to apply those concepts wherever it is required. Then only you can feel the subject bit easy. Okay? So thank you very much. So take care. Bye.